Thank you, Arzu, for your nice introduction. Please let me know if you hear me and you see me so I can start. Do you hear me? Arzu, if you can please let me know if you have my voice. Okay. Um, Hello, everyone. Thank you for taking the time during this tough situation. As Arzu mentioned, I will be talking about new approaches to municipal waste minimization, renewable energy utilization, and carbon footprint reduction. Here is the outline of my presentation. I start with problem overview, followed by integrated municipal waste management, municipal waste to resources, anaerobic digestion, conclusion, and acknowledgements. As we all know, urbanization is presenting our home planet with serious problems. One study by Dr. Smalley identified the top 10 problems of the world for next 50 years. Number one is energy, and then is water and food and environment. And when we look at this list, disease is the seventh in rank. However, with this coronavirus pandemic, we might need to revisit our priority. Recently, we are facing with new species of viruses and microbes that we didn't have in the past. And there is hypothesis that this might be due to climate change, due to environmental pollution that could cause mutation and entering a new variation of viruses and microbes. But definitely energy is one of the serious issues of the world for the next 50 years. In addition, we have growing population. Currently, the population of the world is 7.8 billion people, and this is estimated to rise to 11.2 billion people in 2100. The world in 2100, as a result, will need 3 times the current energy production. Growing population trend of urbanization will result in a huge amount of waste generation. Current municipal solid waste generation level is approximately 2 billion tons per year, and this is estimated to rise to 3.4 billion tons per year by 2050. High-income countries represent only 16% of global population. However, they are responsible for 34% of the world's waste. On the other side, in low-income countries, 93% of waste is mismanaged. On the contrary, in high-income countries, only 2% of waste material is not managed properly. By high-income countries, I mean US, Canada, and European Union. But why we are concerned about waste? The most concerning part about waste generation is consequences to the environment due to greenhouse gas emissions. In 2016, global solid waste production accounted for almost 5% of global greenhouse gas emissions, which was equivalent to 1.6 billion tons of carbon dioxide. And this number is estimated to rise to 2.6 billion tons by 2050. So what we are going to do with this huge amount of waste? Are we going to take waste management strategy just to dispose waste properly so we eliminate harm to the environment? Or are we taking waste reduction strategy? In fact, integrated waste management combines different strategies in order to move forward sustainability. The most preferred option is prevention, then is reuse, recycle, and then energy recovery from waste, and the last resort is disposal. In wastewater sector also, we have challenges about regarding the huge amount of municipal waste. Approximately 330 kilometer cube of municipal wastewater is generated annually. And sludge management, sludge handling is one difficult aspect of every municipal wastewater treatment plant. Sludge treatment is responsible for almost 40% or sometimes more than 40% of operational costs of a wastewater treatment plant. Here we see a typical conventional municipal wastewater treatment plant. Raw wastewater goes to preliminary treatment first that removes large items and floating particles, and then it goes to primary treatment unit where 50 to 60% of suspended solids and portion of BOD is removed, and then we have secondary treatments that removes BOD and nutrients, meaning nitrogen, phosphorus, and here we get sludge that needs to be handled. And lastly, we have tertiary treatment that removes pathogens and nutrients, and then we have treated wastewater. If we use some advanced technology here, we can enhance quality of water, such as, for example, membrane technologies, nanotechnology, then we can improve the quality for reuse purposes. Different techniques have been used for managing municipal waste. One of them is landfilling. Landfilling is a disposal method. So according to integrated waste management, this method is not very preferred, and we are trying to divert waste from landfill as much as possible, and we hear zero waste to landfill and expressions like this. And then the other option is composting, that converts organic material, organic waste such as manure, garden waste, vegetables, to compost and fertilizers that can be utilized for agricultural purposes. And the other method is incineration, that converts waste material to ash. And we can do some resource recovery here. We can recover metal from ash, and also we can power steam generators to create electricity. One other method is plasma gasification. This method, actually here we can also have some resource recovery by utilizing syngas, synthetic gas that can be processed and used as fuel for vehicles. There are other techniques for waste to energy recovery and recycling and waste minimization, and our goal is to minimize waste, to divert waste from landfill as much as possible. So as we see, one of the fundamental challenges of our time is the survival of our planet. And this depends increasingly on finding innovative ways of using our existing resources to meet our energy needs. But did you know one of the most promising way of doing this is to use what is in your toilets or in your garbage bins? Waste materials now are being used to create everything from clean water to electricity. One of the techniques that can be used for this purpose is anaerobic digestion, or AD. AD is a series of biological processes in which organic materials break down in the absence of oxygen by microorganisms. AD is a sequential process that includes hydrolysis, acidogenesis, acetogenesis, and methanogenesis. And the end product is biogas, which is comprised mostly of methane that can be used for electricity, for thermal energy, for RNG, renewable natural gas, and transportation fuel. And the organic residue or digestate can be utilized for to be used as a compost and fertilizers or soil amendments. And here we see that we can get different resources from anaerobic digestion process, such as compost or fertilizers, volatile fatty acids or VFAs that can be utilized in pharmaceutical industry, in cosmetic industry, to create some biopolymers. We can recover biohydrogen from AD. We can recover biogas and ABE, meaning acetone, butanol, ethanol. So our dependence on petroleum and fossil fuel, our dependence will reduce this way by using this technology. The two main phases of AD include acidification and methanogenesis. In acidification, organic matter converts to volatile fatty acids plus hydrogen. And in methanogenesis, acetate and hydrogen that was created in the previous phase converts to methane. Different types of waste material referred to as feedstock can be used as feed to digesters, for example, food waste or biosolids from municipal wastewater treatment plants. But the biomethane potential of each is different. Food waste, for example, has a biomethane potential that is 3 times higher than that of biosolids. But what is the concerning aspect of biomethane? It's good to remember that biomethane has global warming potential that is at least 21 times more than carbon dioxide. So with this technology, we can capture methane and we can prevent it from being released to the environment. The study showed that 6.7% percentage of global greenhouse gas emission results from food waste. This number doesn't seem very significant. It's a small number, 6.7, but a study that was done at University of California showed that they had actually a interesting way for interpreting this number. And that was, if we collect all food waste and create a country out of it, then this country would be the 3rd largest intensive greenhouse gas emitter after China and the US. There are different configurations of this system, and the two common ones that I'm going to share with you is a single-stage digestion and two-stage digestion system. With single-stage digester, we can recover only biogas and digestate. And with two-stage digester, we can control the system in a way that we can recover biohydrogen, VFAs, and ABs in the first phase, and then we can recover biogas and digestate in the second phase. Different parameters can affect quantity and quality of biogas, including pH, temperature, feed composition, mixing, organic loading rate, hydraulic residence time, and reactor design and configuration. But in anaerobic digestion of single feedstock, some problems may emerge that can hinder the process, causing low production of methane. These problems can be alleviated using multiple feedstocks referred to as anaerobic co-digestion. So in co-digestion, we can have a combination of different feedstocks such as sewage sludge, manure, dairy waste, municipal organic waste to increase the efficiency of the system and to overcome those challenges. Good studies have been done, and we have good examples throughout the world. For example, in California, biogas from wastewater treatment plants could account for 125 megawatts of power generation capacity. But if we co-digest the biosolids from municipal wastewater treatment plants with other materials such as fog, fat, oil, and grease, food processing waste, or dairy waste, then this number could increase to 450 megawatts of capacity. That represents 2,500 gigawatt hour per year. So we can get benefits by co-digestion. We can improve the system. We can solve some problems by, for example, dilution of toxic substances that may occur if we had only one single substrate. We could have nutrient balance. Also, by having different combination of waste material, we can have different population of microorganism that increases the synergetic effect, resulting higher methane production. And we can also get economical benefit. We can make revenue from tipping fees. One example is Anahita Island wastewater treatment plant in Metro Vancouver that they are making 490K per year through exporting gas. Also, they're making 572K per year by tipping fees. Now, municipalities are thinking about having centralized facility that co-digest materials and for this purpose, treatment plants are ideal because they have the infrastructures already, they have experience because they already have their anaerobic system on site. And this way we can make economical benefits due to tipping fees, and we can also serve to our environment. To conclude, I would like to say that trends of urbanization and population growth demand serious efforts for enhancing renewable energy utilization. Anaerobic digestion provides a sustainable option because it is a waste management strategy, a waste management technique. In addition, it provides a source of 100% renewable energy. With AD, we can minimize waste, we can divert waste from landfill and reduce carbon footprint. We can heat up our houses, we can light our cities, and save on our tax bills out of our toilets and garbage bins. Finally, I would like to thank Ms. Shohra Sabohpour, founder and CEO of Lumesmart Inc., for her hard work, for her great job, for her commitment to make this event happen. And my gratitude extends to Dr. El Sayed El-Beshbishi, Supervising Professor of Environmental Research for Resource Recovery Group at Department of Civil Engineering, Ryerson University, and Vice President of Central CWQ HCQE. In closing, I would like to remind that researchers all around the world are still going to further utilize waste to resource techniques. In environmental research for Resource Recovery Group here at Ryerson University, our research is focused on resource recovery from municipal wastewater, from municipal solid waste, basically using 80, optimizing anaerobic digestion to recover biomethane, biohydrogen, VFAs, and more. In fact, the word waste is profoundly misleading because it seems that it's waste, but we can make waste to work for us by turning it to a variety of valuable products. And this reminds me of my colleague Frances Okoye when she said once, in environmental research for Resource Recovery Group here at Ryerson University, there is no such thing as waste, only wasted opportunities. In ER3, we work hard, we share our successes, and more importantly, we care for each other. Would you like to see how? Watch this short video. Thank you very much for your time and attention. If there is any questions, I would be happy to answer in Q&A function, or if
You have
not,
4 questions actually in the Q&A.
oh, okay, good. I just wanted to remind that this year marks a 50th anniversary of Earth Day, so happy Earth Day, everybody. Stay safe and thank you. Enjoy the rest of the conference. I'll be with you with questions and answer. So now I stop my screen.
So I think if you just open them at the bottom, then you can answer them live.
Okay. So there are a couple of questions here. I don't know if all of these questions is for me, because some questions seems that it's not for me, but I can answer. I can start with this one. What does it mean, mismanagement of waste? Okay, so we know that we have different types of waste. For example, we have waste that goes to our green bins. We have waste that is plastics. There are waste that are, for example, recyclable, and we have different techniques for each of them. For example, the goal is to send recyclable materials to recycle purpose, for to be recycled. But sometimes they don't go to recycling. And sometimes we have green waste that is going to landfills, while this kind of waste, such as organic waste, can be used for example, anaerobic digestion, for composting. Instead of sending them to landfill, we can manage them in a better way, in proper way. So this is what it is meant by mismanaged. It means that not managing waste in a proper way, in the best way. So verify population in 2025 and 2020. So unfortunately, I don't have a good memory to remember what was the population exactly in these years, but you can, there are different resources that you can refer to. For example, World Bank has good information about this if you need to know what exactly is the population in these years. Okay, so are there any limitations to applying 80 in any environment around the world? I'm not sure about all around the world, but most of the time there are some problems with actually getting approval and this kind of the bureaucracy and these kind of things. And also to convince government to invest in this sector. This is the most important limitation that I can see, because we are used to applying the traditional and conventional methods, and when we are moving forward a new method, this can be sometimes challenging to convince government to switch to a new technology, a new way of applying applying waste management strategy.
Anahita, I'm just jumping in to say we have 4 minutes.
Yes, we have other questions coming up. Okay, I'm not sure if I can. So which feedstock do you suggest for 80? Okay. So as I said, anaerobic digestion is a biological process, and the type of waste that we can use for this technique is the waste that includes biodegradable material or bio-waste. So basically, the proper type of waste that can be used for this technology is biodegradable material or organic waste. For example, it cannot be used for, I don't know, the waste from constructions and these kind of things. So for example, manure. is a good example, or food waste, or garden waste, or sludge from treatment plants. So, okay, so there is another question that asks about a percentage of methane in biogas for the treatment plants that they have in Vancouver. I don't know exactly what percentage of methane they have, but typically somewhere between 60 to 70% of biogas is methane. And we are trying with different techniques. For example, in our lab, we are trying to increase the efficiency to have more methane. For example, by co-digestion, we could increase it by 20 to 25%.
If you want, you can take one more question and then you can type out answers for the rest for social media later.
Oh, okay. So here, I think there was some misunderstanding here that says I mentioned that in 2021, we have 11.3 billion people. No, it was 2100. So 2100. So if I misspelled or it was a slip of tongue, my apologies.
Okay. So
if there is any other questions, feel free to email me at Anahita@Ryerson.ca, and also we can stay connected through LinkedIn. Thank you very much again, and enjoy the rest of the conference. Thank you.